On page 5, we have 3 more pairs of matrices that we're going to try to multiply together. So let's take a look at example 7C. Okay, so here are our 2 matrices. First things first, we've got to check to make sure this multiplication is defined. Okay, so this first matrix, write down the dimensions. It has 2 rows and 3 columns. Okay, so it's a 2 by 3. This second matrix has 3 rows and 2 columns. It's a 3 by 2 matrix. Okay, check the inner numbers. The inner numbers match. Okay, so you're good. You can do the multiplication. The resulting matrix will be a 2 by 2 matrix. Okay, so we are going to set up a template. Okay, I'm going to draw out a 2 by 2 matrix. Okay, so we're expecting something with 2 rows and 2 columns. Okay, so it's going to look like this. Okay, and then we're going to fill in these numbers by doing dot products. Okay, all right, so let's start here. Okay, so in our matrix that we're trying to form, this is the first row, first column. So we're going to go and do the dot product of the first row, first column. Okay, so you're going to multiply the corresponding numbers together and then add them up. Okay, so multiply the first numbers together, you're going to get 1 times 2, then the middle numbers, that's going to be 2 times 3, and then the last numbers 1 and 2. Okay, add them up. Okay, so that's how you do that one. Okay, so moving on. Okay, so you can do really you could do this in any order. Okay, I'm going to go over here. This is the first row, second column. Okay, so now let me erase this. Okay, since this position is the first row, second column, I'm going to do the dot product of the first row, second column. Okay, so multiply your corresponding elements together. We're going to get 1 times 3 if we do the first numbers, then the middle numbers 2 times 1, and then the last numbers 1 times negative 1. Okay, add them up. Okay, all right, down here. Okay, what's the position of this element? Okay, this is the second row, first column. Okay, so you need to go back and identify which row and which column you should work with. Okay, you're going to use the second row, first column. Okay, so you're going to do the dot product there. Okay, multiply corresponding elements. Okay, so do the first numbers together, so 3 times 2, the middle numbers 1 times 3, and then the last numbers 3 times 2. Okay, add the results. Okay, last position. Okay, this guy is located in the second row, second column. Okay, so let's go identify what we need to do the dot product of. Okay, we've got to use the second row, second column here. Okay, so multiply your first numbers together, 3 times 3, your middle numbers, 1 times 1, and then your last numbers, 3 times negative 1. Okay, add them up. Okay, so now we can just simplify all these, dot products, and we'll have our final matrix. Okay, so right here in the top left, first row, first column, we have 2 plus 6, that's 8, plus 2 is 10, is going to go in the top left. Okay, in the first row, second column, we have 3 plus 2 is 5, plus a negative 1 is going to be 4. And then second row, first column, okay, we have 6 plus 3 is 9, plus 6 is 15. And then the last position, second row, second column, we have 9 plus 1 is 10, plus a negative 3, 10 minus 3 is 7. Okay, so if you multiply the 2 matrices together, okay, here is the matrix that is formed. In example 7D, we are going to multiply or try to multiply 2 3 by 3 matrices. So let's pull this up. Okay, so right here, here we go. First, got to check to make sure that we can do this. Okay, so again, this is a 3 by 3. This is a 3 by 3. Okay, check the inner numbers. Okay, this number matches this number. So the number of columns in the first matrix is equal to the number of rows in the second. So we can perform the multiplication, and then the result will be another 3 by 3 matrix. Okay, all right, so let's go ahead and map out a 3 by 3 matrix. Okay, so this is going to be pretty big. Okay, so I'm going to try to squeeze it in here. We need 3 rows and 3 columns. So here we go. Okay, really, really helps to map it out. Okay, all right, so let's start. Okay, so this is in the product. Okay, product just means the result of multiplication. This is the first row, first column. Okay, so we're going to do the dot product of the first row, first column. Okay, so multiply corresponding elements together, add them up. We're going to get 5 times 0, the first elements, then the middle elements, -2 times 3, and then the last elements, 1 times 1. Okay, add them up. Okay, all right. I am going to go ahead and simplify as I go. All right, so this simplifies to be 0 plus a -6. So -6 plus 1 is -5. Okay, all right, next. Okay, it doesn't matter where you go next. Okay, I'll do the first row, second column. Okay, so now we need to do the dot product of the first row and the second column. Okay, so if we do that, we're going to get 5 times 4, and then -2 times -6, and then 1 times 1. Okay, add them up. Okay, this will be 20 plus a positive 12, that's 32, plus 1 is 33. Okay, all right, one more element in this row. Okay, so we'll go ahead and do the first row, third column. Okay, so first row, third column. So you're going to do the dot product of the first row and the third column. Okay, so we're going to get 5 times -1, and then -2 times 5, and then squeeze it in here, 1 times 2. Okay, add them up. Okay, so we're going to get -5 plus -10. Okay, that's -15. Plus a positive 2, that's going to be -13. Okay. All right, we're done with the first row. Okay, so moving on to the second row. This is the second row, first column. Okay, so now we need to do dot product of the second row, first column. Okay, so we're going to get 0 times 0 plus 4 times 3 plus 2 times 1. Okay, we simplify, we're going to get 0 plus 12 plus 2, that's 14. All right, moving on to second row, second column. Okay, we're going to dot product the second row, second column. Okay, so we're going to get 0 times 4 plus 4 times -6 plus 2 times 1. Okay, clean it up. This is going to be 0 minus 24 plus 2 is -22. Okay, all right. Last element in this row, this is the second row, third column. Okay, so you go and you do the dot product of the second row, third column. Okay, we're going to get 0 times -1 plus 4 times 5 plus 2 times 2. All right, so we're going to get 0 plus 20 plus 4 is 24. All right, 3 more elements to go. Okay, so right here, this position is the third row, first column. So we need to go and do the dot product of the third row, first column. Okay, so we're going to get 1 times 0 plus 6 times 3 plus 3 times 1. Okay, so this will clean up to be 0 plus 18 plus 3, that's 21. Okay, second row, second column, we need to do the dot product of the, oops, sorry, said the wrong thing here. Okay, this is the third row, second column. Okay, so we've got to do the third row, second column. Okay, so we will get 1 times 4 plus 6 times -6 plus 3 times 1. Okay, all right, let's simplify. We're going to get 4 plus a -36, that's -32. -32 plus 3 is -29. All right, in the very last spot, third row, third column. Okay, so we need to do the dot product of the third row, third column. Okay, so we will have 1 times -1 plus 6 times 5 plus 3 times 2. Okay, so we will get -1 plus 30 is 29. Okay, 29 plus 6. Okay, that's going to give us 35. Okay, so if we multiply those two matrices, here is the result. Okay, next, in example 7e, we are multiplying these two matrices. Okay, so we have the identity matrix. Okay, that's an identity matrix, that's I2, times this other 2 by 3 matrix. Okay, let's first check to see if we can do it. Okay, this is a 2 by 2. Okay, this guy is a 2 by 3. Okay, so if we look at the inner numbers, they match. Okay, so we can do the multiplication, and the resulting matrix will be a 2 by 3 matrix. Okay, let's go ahead and map this guy out. So draw yourself something with 2 rows and 3 columns. Okay, so like this, and then we'll start. All right, so first element, this is the first row, first column. We need to do the dot product of the first row, first column. Okay, so multiply corresponding elements, add them up. Okay, so let's do the first numbers, 1 times 1, and then the last numbers, 0 times 7, add them up. Okay, moving on. Okay, this is the first row, second column. Okay, so let's do that dot product. Okay, so we're going to do first row, second column. Okay, that is going to give us 1 times 4 plus 0 times -3. Okay, next is the first row, third column. Okay, if we do that dot product, first row, third column, we shall get 1 times -2 plus 0 times 5. Okay, moving on to the second row. Okay, this element is in the second row, first column. So we need to do the dot product of the second row, first column. So that's going to be 0 times 1 plus 1 times 7. Moving on to the second row, second column. Okay, we will do that dot product. So second row, second column. Okay, so that's going to give us 0 times 4 plus 1 times -3. Okay, last spot is in the second row, third column. So we will do our dot product of the second row, third column. Okay, and we will get 0 times -2 plus 1 times 5. Okay, let's go ahead and clean it up and see what we get. Okay, so 1 plus 0 is 1. Okay, 4 plus 0 is 4. -2 plus 0 is -2. Down here, 0 plus 7 goes in the second row, first column. And then 0 plus -3 is -3. And last spot is 0 plus 5. That's 5. Okay, so here is the matrix you get when you multiply. Okay, all right. That's the answer. Okay, if you notice here, you may not notice because you're probably concentrating on just doing the multiplication. Okay, what we did in this example, we took the identity matrix and multiplied by another matrix. Okay, and look what we got. Look at this. Look what this is. This is the matrix we multiplied the identity by. Okay, so what you should learn from this, okay, if you multiply a matrix by the identity matrix of the appropriate size, if that multiplication is defined and you're able to do it, multiplying a matrix by the identity matrix is going to leave the matrix unchanged. You're just going to get that matrix back. Okay, so that's another cool trait of the identity matrix. Okay, all right. Another thing before we move on, let's look at the very bottom of page 5. Okay, there's 2 bullet points here. The second one is what I just told you. So if you multiply by an identity matrix of the proper size, it does not change the matrix. So that means if you're, I is reserved for the identity matrix. So if you take the identity matrix of the appropriate size and you take another matrix A, if you do I times the matrix A, you're just going to get that matrix A back, okay? And remember, we talked about this. The order actually matters for matrix multiplication. Order matters, okay? So in this case, you were multiplying I times A. In this case, you're doing A times I. If you did that, if you were able to do that multiplication as well, you would also get the matrix A back. Okay, so again, if you are able to multiply a matrix by an appropriate identity matrix, it will leave that matrix unchanged. Okay, another thing, and we've touched upon this, but let's emphasize this again. Okay, matrix multiplication is not commutative. Okay, so that's a fancy word for saying order matters with matrix multiplication. Okay, and actually, I'm going to go back to a previous page because you probably didn't realize that we were doing this. Okay, let's go back to, let me see where it is. Okay, when we first started doing matrix multiplication, when we first started example 7, okay, look at 7a and 7b. Okay, look at what we got. Okay, notice, and you may not have picked up on it, these in both examples A and B, we had the same two matrices. Okay, this matrix right here, the 1, 3, 1, 3, 1, 3, that's the same matrix as this matrix down here on the right in part B. And then the other matrix is the 3 by 1 matrix, the 4, negative 2, 4. This matrix is the same as this matrix. So we did the same multiplication. We were multiplying the same two matrices together, but we did it in different orders. Okay, so here we did the 2 by 3 on the left and the 3 by 1 on the right. And then in part B, we just switched the order of multiplication. You got different results. Okay, so when you multiplied them in part A, you actually got a matrix as the result. But then part B, if you switch the order of multiplication, you couldn't multiply them that way because the number of columns in the first matrix didn't match the number of rows in the second. So this was an undefined product. So it's very, very important that you notice that matrix multiplication, the order matters. You may be able to multiply the matrices in one order, but not the other order. Okay, if you switch the order, you may not be able to do it. And this is a great example of that. Okay, so just keep that in mind, that order matters when you are multiplying matrices. Okay, let's move on.